Shri Gurubhyo Namaha children, welcome to our online teaching academy, Ekalaiva. Through this we had learned lesson 1 completely, lesson 2 here going to get over within a few more topics. Here the next topic of this lesson is motion of a freely falling body. So free fall, which means that nothing is placed on it to pull it. If I have a chalk piece in my hand, if I throw on, what will happen? It will automatically fall down, isn't it? It is called free fall. So to understand it very deeply, we are going to learn with some more activity. To do these activities, we need to have stone, eraser and plain. There are two papers, plain sheet of papers. Another paper we have to make into crumble like a ball. Okay, so to do this activity, what are the things we needed? We need stone, eraser, papers. Now, activity 1, stone and eraser. Okay, stone and eraser reaches the surface of the earth almost at the same time. So, when I have a stone eraser in my hand, if I throw it up, which will come down? We cannot predict because both will reach the ground at the same time. This is activity 1. Now, activity 2, the eraser and the paper. Between what are the object ma? Eraser and paper. You know how it will be, isn't it? So, the eraser reaches the first down. Okay, eraser will reach the first, followed by which will? A plain sheet of papers. So, compare earlier, same time. Now, in this case, eraser fall to the ground very first. Okay. Next, the third activity, the plain sheet of paper and crumbled paper. Both are paper only. But what is the difference? One made into crumble like a ball, isn't it? So, when it thrown up, what will happen to that? No, the crumbled paper, even though both are having an equal mass, the crumbled paper reached the ground first, followed by the plain sheet of papers. So, do you know the reason why these are the difference to reach the ground? Okay, that we are going to learn through this. When all these, okay, it may be a stone or eraser or crumbled paper or a paper, irrespective of any object, when all these objects are dropped in the absence of air medium. See here, absence of air medium, which means we can call it with the other word vacuum, okay, which means no air. Okay, we can call the vacuum is there is no air, only called as a vacuum. In the absence of air, what will happen to all the objects? No, all would have reached the ground at the same time. Do you remember the activity with the air? Both the eraser and stone reached the ground, then eraser reached the ground first, then followed by crumbled paper reached ground first. So, these are the variation. But when there is no air, what will happen to all the object, irrespective of any object, all will reach the ground simultaneously. So, then when air is present, see here, in air medium, air offers some resistance. Okay. You know, resistance means it plays a role over there. It will make the paper to be there in some more time. Okay. So, resistance to the motion of a freely falling object. So, that is the reason paper did not fall easily or quickly into the ground compared to the stones and eraser. That is also, I will give you a reason. So, between this, when there is no air, all will reach the ground simultaneously. When there is air, what is the work it is doing? Air offers some resistance to the object. So, in the case of stone and eraser, this air resistance is negligible, which means not acted on it more. So, but it is negligible small when compared to the gravitational pull. Okay. So, when we throw any object, all will fall down. No, due to what? Due to gravity. But here, in the case of stone and eraser, along with the gravity, some air will also resist some force. No, that is small. Okay, that is negligible small. So, due to that, which is acting more now? Gravitational pull is acting on it more, so that it falls down easily. Okay. So, hence they are reached the ground first. So, due to this reason, so air resistance is negligible, so that gravity pull act on it quickly, so it reach the ground simultaneously. I've told you absence of air, presence of air. So in the presence of air also, the magnitude of air resistance, okay, the direction, the size, place, okay, all this depends on magnitude. So air resistance depends on area of an object. Remember the area of a eraser or stone or a paper or crumbled paper, which area is bigger? As obviously the plain sheet of paper area is bigger. So the air resistance depends on area of the object. So that depends on the area air will expose on it. So due to that it will offer some more resistance extra. Okay, so due to the area is bigger. So we know that an object experiences acceleration during free fall. So what will happen? No, any object, so air plays a role. Okay, along with that, any object is falls down or going when it's thrown up, it goes up, no, upward. So when it goes upward or falls down, it will get acceleration. What is acceleration? Change of velocity. Okay. So it is acceleration is what? Change of velocity with respect to a time is called acceleration. So due to changes, what happened to this? No, the any object when it throws, there is a change in velocity. Due to that object get acceleration. That is called accelerated motion. This acceleration is independent of mass, which means what? It may be a big object or big or small or a hollow object or solid. That is why the acceleration is independent of mass, which means whatever the object is throwing up or falling down, going upward or coming downward, so it will get acceleration. It is not dependent on mass, it is independent of mass. So with this you learned how air will resist it depends on the area. So all the object will get acceleration, isn't it? So that what will happen? No, we have to get the equation of motion for a freely falling body. We have to derive a equation of motion for a freely falling body also. Already in previous class we had learned a equation of motion. 3 equation of motion was given by Newton. No. So do you remember that 3 equation of motion? The first one is V equal to U plus AT. This is first equation of motion. Second equation of motion, S equal to UT plus of AT square, and the third V square equal to U square minus 2A. Yes. So these are the 3 equations of motions. With the help of these 3 equations, we are going to derive a equation of motion for a freely falling body. As I said earlier, free fall means before it falls, initially do it have any velocity? Nothing. So the initial velocity will represent by U. It is represent value of 0. No changes, no. So initially it is 0. Then so all the body will get acceleration, isn't it? Due to what? Due to gravity. So acceleration will represent by A. So all the object will get acceleration due to gravity. So that the A will depends on the gravity. Though it's going upward, okay, vertically, so that will measure with the help of height only, no. So here the distance is given as S. So in the case of motion of freely falling body, instead of S, the distance will measure by height. With this, we are going to, with the help of this assumption, we are going to derive a equation of motion of a freely falling body from the equation of motion. Ready? Now apply the values. Okay. First is V equal to U is what? 0. So that let it be a 0. U plus AT that is u is 0, so which will be remaining? Instead of a, what has to be replaced? It is replaced by g, so gt. Okay, this is the first equation of motion of a freely falling body. So let me write to clear, v equal to gt. Okay, and the second one, s equal to ut plus of at square. So u is 0 means u into t obviously 0, so no need to write. So plus, okay, which is remaining? Of, instead of a, which letter has to be written here? G. G is acceleration due to gravity, then t square. This is second equation of motion of a freely falling body. So what is the remaining? Here instead of s, which has to be in h equal to of gt square. Okay, and the third, v square equal to u square minus 2as. Okay, v square, u is what ma? U value is 0, so that 2, a is equal to g, s can be written as h. Okay, this is how, this is the v equal to gt of gt square and 2gh. These are the three equations of motion of a freely falling body. Next, so we know, as we know, a equal to g, okay, it will also get a positive or negative sign. How? No. So when I throw a stone on the upward, what will happen? It will. So when I throw a stone up from here, no, it will reach upward where it gets 0, where it attains 0. From there it will fall down. Okay, so a equal to g. So when it goes up, so gravity will pull towards downward, isn't it? So against the gravity, the object is going upward, so that it is represented as minus g, negative. Okay, so where it attains 0, it will fall down. No, so what happened? No, it is simultaneously coming downward along the force of gravity, so that it attains the plus g. Okay, I hope this equation of motion of a freely falling body with the equation you all have understand easily. Thank you children, we will see you on next class.